mynews.studio.
A man, paralyzed for years, walks again, his legs moving just by thinking about it. Could this shift our whole approach to paralysis?
Today is July 9th, 2025. Let's dig into this breakthrough. Back in 2011, Gert-Jan Oskam was paralyzed from the hips down after a motorcycle accident. For over a decade, he couldn't walk. Then, in 2024, Swiss researchers did something different. They restored natural walking in a paralyzed man by creating a digital bridge between his brain and spinal cord. How exactly did they manage that?
It all started with a brain-computer interface, or BCI. They implanted sensors called WIMAGINE just above the motor cortex. That's the part of the brain that controls movement. These sensors detect the intention to move and send that signal wirelessly to a neurostimulator on the spinal cord. The neurostimulator then activates the leg muscles, following the decoded brain signals. So, the damaged part of the spinal cord gets bypassed. The man's thoughts are translated directly into movement.
But it's not just simple movement, right? Oskam could stand, walk, and even climb ramps with only a walker. And after a year using the implant, he managed to walk with crutches, even when the device was off. How do we interpret that in terms of recovery?
That's a crucial point. It suggests the technology doesn't just substitute for lost function. It may also help reactivate neural pathways that were dormant. That's likely why Oskam could still walk a little, even when the system was switched off. So it's not only about the device, it's about retraining the brain and body together.
And the whole setup is wireless. So Oskam is controlling his limbs himself, not just relying on automatic stimulation. That sense of agency, why does it matter so much?
Because it's his intent driving the movement. That gives him independence and a psychological lift that traditional therapies often don't. Instead of just being moved, the patient is actually regaining control over his own body.
But access is still limited. This only happens in specialized centers right now. Is there a path toward making it more widely available?
Researchers are working toward that. The teams in Lausanne and elsewhere are refining the technology to make it simpler and more durable. They've already shown patients walking outdoors, climbing stairs, outside the lab. The next steps are bigger trials and bringing more hospitals into the process. The idea is to standardize the surgery and rehabilitation so more people can access it.
But the cost and accessibility are still real issues. These are advanced implants, and the training is complex. Most hospitals can't just start offering this. Are there efforts to simplify things?
Definitely. Making the devices easier to use and less dependent on specialized equipment is a major focus now. Streamlining the whole process will be key for broader adoption.
And what about risks? Surgery on the brain and spine isn't minor. What are the most significant concerns here?
There are risks during surgery, like infection, device malfunction, or tissue reaction. Then, long-term, the implants have to be safe, durable, and biocompatible. That's why every trial includes regular monitoring, and regulators require strong safety data before broader use.
And privacy? These implants are decoding and transmitting brain signals. How is that information protected?
The systems use secure wireless protocols with strong encryption and controlled access. Patient data stays private. Only authorized staff can see it. As the field grows, new ethical guidelines and regulations are being developed to keep patient rights and data privacy at the center.
There's also the psychological impact. Regaining the ability to walk after years of paralysis, it must be a profound change.
Yes, patients often describe a new sense of autonomy and hope. The immediate feedback, standing, walking, climbing stairs, can change daily life. But the process is demanding. Rehab is intensive, and not everyone becomes fully independent, so ongoing psychological support remains vital.
This isn't just about one person. Worldwide, millions live with spinal cord injuries. Could this approach change what's possible for them?
It marks a new era in treating paralysis. With more development, these systems could become a standard part of care, and for some, might even remove the need for wheelchairs. The combination of neuroscience, engineering, and AI is shifting what's possible.
But it also raises questions. Where do we draw the line between therapy and enhancement? How do we regulate brain-machine interfaces?
Those are ongoing debates. As the technology advances, society will have to consider how to balance access, safety, privacy, and ethics.
Today, a paralyzed man walks again, powered by his thoughts. What was once science fiction is now reality in the clinic.
Thank you for joining us. We explored how brain-computer interfaces are restoring mobility, the progress and hurdles, and the new questions as technology and medicine converge.
Thank you for listening. This episode was brought to you by mynews.studio. You can try it now for free.